let's take a look at my answer. So I personally subscribe to the idea that the startup founder in 2035 is still probably a human for all intents and purposes, but they are heavily armed with, this exoskeleton. I think is a very good metaphor, right? Like it is still the human that is at the center of that startup idea and the startup operation, but they have an army of, hopefully autonomous agents, semi-autonomous agents that are helping them do a lot of interesting things. And this is an interesting future. Of course, a lot of the other futures that you pointed out, like OpenAI is the singularity company and it has taken over everything, that's a possibility. But this is the possibility that I would like to subscribe to, and I'm going to do my best to make sure that this is the future that we will end up in, right? And I'm hoping that all of you also um, try to move in that direction rather than the alternatives. And this is attractive to me because it is very powerful. Like a few of the ideas mentioned, startup founders will not look like I don't know, Zuckerberg. They look like, an everyday person who is from whatever background and they had an idea and they made it happen, right? I run a boot camp for entrepreneurs to help them build custom agents. And something that I have been seeing in the past easily 6 months or so is that we are getting people from very, very, very non-technical backgrounds come to the boot camp within 7 weeks. They build very reasonably sophisticated software, and they launch. And these are like people from project management, product management, sales background, marketing background, people who probably, up to 3 months ago had not written one line of code. And today, they're actually launching a software into the market. There's a whole list of questions to be asked about the security of that software, robustness of it, how it will potentially blow up, etc. But the fact that people feel empowered to try, I think, is a very, very important point of this technology, and hopefully what we all will move towards and eventually have, somebody that is quite kick-ass with regardless of their background, regardless of where they're coming from, but they have an idea and they want to chase it, and they have an army that can help, right? Like that's the future that I'm hoping to see. And today in this tutorial, I'm going to hopefully set you on the path, if you're already not, to go towards this. Right? Does that make sense?
I'm curious, you said it was the future you're hoping to see. I was curious why.
Why? Well, I'm an entrepreneur and I would like to see everybody be an entrepreneur, right? I have previously worked in corporate and 9 to 5, and the constraints of it didn't fit what I wanted to do with my life. I wanted to do something that is meaningful, purposeful for me. And when I talk to my colleagues that are in 9 to 5 jobs, I all like some of them, like a small 20% of them are very happy. Like, if they figured out how they want to live their life, they figured out the balances of everything. But the 80% are just doing it as a pragmatic, it pays my bills kind of thing. And you're spending at least 80 hours of most of your days doing that. Do you want to spend your life doing that? And I think a lot of people don't jump into entrepreneurship because they're like, oh, I'm not an engineer. I don't know how to do internal operations. I don't know how. They don't make the jump because the barrier of entry is huge.
Mhm.
But now, if we reduce the barrier of entry, like think about 20 years ago. 20 years ago, servers lived in your basement, in your garage.
Mhm.
Today, 5 minutes, you just go to AWS, go to alternatives of it. You have a big server, completely expansible, ready to go. You can deploy everything, right? So cloud technologies was an empowering technology more than anything. Like it allowed somebody who does not have connections, who does not have infinite amount of money to figure things out, to just be part of the game. Like the fact that I'm part of the game is because of the revolutions that we've seen over the past 2 decades. And this is the most important revolution we're going to experience over the next decade. So I would like to be a messenger of, this is empowering you to build whatever you're imagining. Like, a lot of, as I said, like a lot of people in the boot camp, they're like, I'm working in operations, I'm working in program management, partnerships, whatever. Like it is completely non-technical. Like they have not
Right.
imagined, right? And they feel empowered to do it today. And that's great. That's exactly what we want. We want people to feel empowered to do something that is meaningful to them, right?
See, I really agree with you.
Yes.
And I think it's really important. How do you wrestle with the success rate of entrepreneurs?
That's a very good question, and I will talk about that.
Okay.
All right. So let's move forward. If I can orient myself. There you go. Okay. So in that future that I described in 2035, the imagination that we have is, autonomous systems that are capable of navigating the messy, complicated, oversaturated world that exists around us, right? Like we're hoping to have an autonomous system that can navigate. And I'm, using this metaphor of this robot on a bicycle, just as a metaphor, like you can expand it to any type of autonomous system that we have, right? We would like them to, if you have an autonomous sales agent, we would like it to sit inside a complex sales process that we have and actually help us, right? Like that's what we want. But the reality of today, given where the technology is that, mostly we can do this kind of thing, right? But we are very quickly moving towards figuring out how systems should be built in a way that we can actually get to a point where we have autonomous systems that actually operate and help and integrate into everyday life that is messy, unpredictable, and a little bit crazy, right? So this is just the contrast that we have to keep in mind. Like, yes, that's a beautiful future we want, but this is where we are, and we have to build our way to it, right? So, like, sort of reflecting back to what Vicky was saying yesterday, that beautiful future that we want might not happen if we just don't go through the work, right? Don't go through the steps of getting the reps in, figuring out what problem solving is like, so on and so forth. Like a lot of people who believe that that's where we are, they're vibe coding. They're just going to the, whatever, insert name of application, lovable, whatever, and they're like, build me an application. And that doesn't work. That blows up in your face as soon as you put it into the real world because, as soon as you post it on social media, somebody's going to be like, I'm going to hack this so that you understand how, so understanding where we are, I think, is very important. Understanding that there are reps necessary. Like you have to go to the gym every day and do reps with your brain now, instead of in addition to your muscles, so that we can actually build towards that future. So with that, hopefully opener, I want to tell you a little bit about myself, so that you also understand why I'm here and why I'm talking about these things. I was told that I always talk about professional things and not on the personal side. But here are three things I like. I like reading and writing. I really like coffee. Like I spend 20 minutes every morning hand grinding my coffee. That's like the slowest part of my day. It's amazing. I recommend it. And I used to be a long distance runner, but I messed up my knees, hamstring, ITB, all the above. So I can't, as you can probably tell. But on the professional side, I'm 2 lives ago, I was a physicist. I did a PhD in quantum computing at the University of Toronto. Then I worked at the University of Oxford for a couple of years. Again, in the same field of quantum computing. I had some patents in quantum computing, and that was my first attempt at entrepreneurship. I tried quantum tech company. This would be, 2016 or so. No market. So I dropped that idea and I said, okay, the next best thing after quantum computing is AI. So went back to Canada from England and started working in a financial institute as a data scientist. I was very interested in natural language processing, which is how do you apply AI on documents. And as a scientist in my previous life, that was very attractive to me to be able to use AI on documents, on knowledge documents, and so on. So that's what I did for about 3 years at Royal Bank of Canada. I was extremely bored at my corporate job, as I mentioned a minute ago. So in 2018, I started building a community in Toronto, and this community was literally texting a few people saying, "Hey, do you want to get together, eat pizza after work, and talk about AI?" And they were like, "Yeah, why not?" So we started doing that. At some point, we were doing 2 or 3 events a week in person. So that's like, again, way before pandemic lockdown and all that. This is a link to the Slack workspace that the community lives. The community is still there. We have about 6,500 members. It's very global, no thanks to the pandemic lockdown. But you all are welcome to join. There's a lot of discussion about AI, job opportunities, can post job opportunities or see job opportunities, resources, discussions, etc., etc. And um, we meet every Friday to discuss topics like what I'm presenting today. After that, or as somehow as a result of starting a community, I ended up starting a company called Aggregate Intellect. And the name is a little bit of a weird name in your mouth, I admit, but really I was going for something that means collective intelligence, but abbreviates to AI. And I ended up with that. And the original idea of the company was redefining scientific discovery. So being a physicist and having discovered AI, I was like, oh my God, can I get AI to read papers and tell me what is important? Something that we do almost trivially today, but in 2019, when I started the company, with the natural language processing that was available to us at that time, it was a little bit of a jump. And obviously, we were not very successful in that. So we started pivoting like any good startup. So after figuring out that AI on scientific content was not going to work, we spent a little bit of time figuring out if AI applied to education would be interesting. So we tried that for a while. And all of these cases is, really applying AI to documents. Again, like something that is quite trivial today, but again, in 2020 was the beginning of it becoming more feasible. After that, given that we had a community and some core tech built, we tried to do an R&D marketplace. The core idea was, can we connect members of our community to corporate R&D teams and allow them to collaborate and build cool stuff? Again, like using the text that we have in the middle. And then out of that, we learned that knowledge management in corporate innovation is a very, very difficult problem. What we learned was that people call note-taking knowledge management. They are sitting down and writing notes, and they're calling it knowledge management. And a lot of the time, I'm like, as soon as I started going a little bit deep in it, it was very clear that it was very much a vanity metric, in a sense that how much documentation of whatever you have is not necessarily capturing the knowledge that your organization has, capturing the knowledge that your team has. And then importantly, these knowledge management tools become a swamp of notes and documents. Like if any of you have worked at a corporate and have interacted with the intranet there, it is completely impossible to figure anything out. Like you have to go ask Joe where that document is so that you can then go use it, right? And that is not knowledge management. That's just corporate metrics, text, and moved on, right? So we started figuring out, okay, can we build a product that makes that a little more easier? Again, something that is very achievable today, but in 22, 23, it was really starting to come to the forefront. Like if you remember, that's where ChatGPT had come out. And in the majority of 2022, that was not available. So when we were talking to corporate innovation teams saying, hey, you're doing knowledge management wrong, you could use language models and graphical models to do this differently, they were like, I'll just Google it, our search is fine. And then all of a sudden, ChatGPT came out and everybody was like, oh my God, what is this? So obviously, we were not doing it right. Otherwise, we would have convinced a few people. But fast forward to today, given all the interesting things that have happened between beginning of 23 until today, what my company is very focused on is what I call human machine teaming. Like we are very, very interested in research and development on how teams of human and machine knowledge workers can collaborate to get stuff done, right? So that's what we are actively working with economists, social scientists, organizational design people, computer scientists, and ourselves as NLP people. We are working in an interdisciplinary team to figure out what does even an organization of knowledge workers going to look like in 3 years. We do not know, right? Like we have guesses, but at the rate in which we are seeing layoff, we are seeing organizational redesigns, we are seeing a lot of changes happening, a lot of the standard operating procedures are being revisited. Um, so a lot of these are signals of what is coming up, but we don't know what it will look like, right? So we are trying to simulate that future.
Do you have any, thank you, and I'm very curious, but if I ask too many questions, please feel free to tell me, Amir.
Yeah.
Tell me, have you had data on the acceleration of humans and AI together? Like whether it's just in a particular use cases, like in finance,
Yep.
you will double your output. Like, is there any actual like placebo controlled, double blind?
Yeah. Yeah. I mean, there are a lot of studies that are coming out. The problem is that my economist collaborator calls it these are fairy dust experiments, which is like you grab an organization and you fairy dust AI on it and then measure the impact. That's not how it's going to work. Like essentially, an AI first organization will potentially look completely different. Like when you just retrofit AI into an organization that has constraints, has solid structure, has inertia to change, you're not going to be able to measure the impact. Yes, there are numbers coming out, but all of them almost have that criticism that they are essentially retrofitting. Like it is like grabbing a PS and jamming in a Lamborghini engine in it, right? It's not going to go faster. Like it doesn't have the right structure to go faster. So there are numbers, but numbers are not really that reflective of what it will be.
What have you seen work? And what's the multiplicative factor?
Oh, engineering, software engineering. Absolutely, 100%. I will talk about that. Yeah.
1.5, 2x, 10x?
It depends. Like I am like, as I said in the previous slide, since about maybe 2018, I stopped writing code because I was pulled into management. I was a product manager, and then a startup founder, didn't really have time to write code, etc. Since last summer, I have written maybe 60% of our code base. Like, how are you going to put a number on it? It was 0, now it is significant, right? Like, it really depends. Like, my very senior engineer, my CTO, maybe he's gaining a factor of 2. I'm getting a factor of infinite because I would not have done it otherwise, right? And I think that's the interesting part. Like that distribution of empowerment is the interesting part.
So you think it's a power curve?
Absolutely, 100%. Like we just very recently deployed a sales agent in a lumber yard, out of all places, right? So they have very complex sales processes, and especially during construction season, they get a significant amount of inbound. Like everybody's like, I'm building this house, like give me a code. And they're sending that to 5 lumber yards. And whoever responds faster, cheaper, more accurately gets the deal, right? So their game is very straightforward. Respond fast, quick, and on point. Like, reduce any back and forth. And during their heavy season, they're getting like tens of these per minute. Right. So solutions, increase the size of your sales team, or try to figure out how to use agentic AI. And this particular private equity firm came to us. We worked with them. They deployed it. Today we have numbers in production, and the numbers are like their best person. She's a very young person with really good memory. Like that just happens to be an individual that is very good at remembering things. Right. She has the whole list of SKUs memorized. That person is seeing maybe 50% improvement. The person that types like this, on a computer, he's saying 7 to 8x improvement in terms of how quickly they can get the jobs done, right? So it is definitely going to be a spectrum. It's definitely going to be a very long tail of people who are going to see ability to do things that prior to that was very, very difficult for them or literally impossible. Is there a question in the back?
Thank you, thank
Yeah,
you.
we'll discuss more afterwards. All right. So, and of course, like, um, this gap in the middle is, what I said, ChatGPT came out in that at the end of 2022, beginning of 2023. And, that moment was a deciding moment for us. Do we want to double down on that knowledge management tool or do we want to do something else? And we decided to just open source what we had as our tech and really focus on research and development and service. And today, for example, we do AI enablement in very high touch professional services because those are quite interesting. Like they are what I call them emotional intelligence as a service company. So AI is not super good at dealing with those kind of things, and especially because they get paid a lot of money to do stuff. You cannot just copy paste things from ChatGPT to them. So how do these companies gain efficiency? That's a very, very interesting problem. Like what kind of organizational redesign is necessary for that to happen? So moving on from this a little bit. So I think it is always helpful to. This is more of a recap, I guess, for the beginning part of what I have to say. So we eat our own dog food. Like the number that you see on the very left is that since 23 we have almost 10x our revenue, and my team is from 10 people has gone down to 2 people. And we use a lot of agentic systems in our engineering, product, sales, financial modeling, you name it, we're probably doing it. And somebody asked me yesterday, like I told them that number, and they asked me if that means that the people became redundant. I think if I was a better business person, I probably would have grown my company much faster and kept everybody and was growing at a much higher rate. But we are growing at whatever rate, and therefore we don't need as many people as we used to maintain that rate of growth that we currently have. So that's proof. Like it works. We are already at the beginning of this, right? And I'm not going to say that all of this is due to AI. A portion of it is. The portion of it is, me as a physicist finding my way in the business world. That's definitely a factor. There are probably 10 other factors, but definitely, AI is a part of it. As I said, I'm writing a significant amount of our code just because I don't have to remember syntax anymore. And I will tell you my process work. And by the way, that's our website, AI.science. Go there, check things out, etc. Okay, so usually you're going to walk out of this room today and you're going to meet somebody or go home, talk to your family or one day at work, and they say, what was the best talk at the conference? You're going to say, oh, this one that Amir gave, right? And they say, oh, what's the company about? And you're going to say, oh, AI.science is the website because that's easy to remember, right? And then you tell them it's a knowledge ops company. And they're going to say, oh, what is knowledge ops? I'm going to equip you with an answer. So knowledge ops is a concept that we came up with. It's a framework. If you scan this, it will take you to a manifesto that I wrote about knowledge ops. Not for technical people here. Everybody? Okay, most of the room. So for those of you who didn't raise your hand, there's this concept called DevOps. Came out 10, 15 years ago, I don't know, 20 years ago. And the core idea of it was that development and operations of a software should not be separate. They should be done together, etc., etc. And I think the most important thing that DevOps did for software development was that it removed the barrier of experimentation. Because prior to that, you had to design all of your things. Then you had to develop all of your things. Then you had to just throw it over the wall to the operations team. They will take their sweet time to put it in production. Then they operationalize it. Then, like 6 months later, they're like, oh, yeah, by the way, this feature doesn't work. And then you go back to the drawing board and you repeat the whole process again. What DevOps did was that it used processes, like essentially human standard operating procedures, a different mindset, and a lot of tooling that allowed for monitoring and automation, and brought this whole circle of going back and forth between development and operations from like potentially multi-days, multi-weeks to probably a few days, right? So within a few days, you get a signal that, oh, this thing didn't work. And if you're doing it right, you get that signal within a few hours. Like famously, big tech companies are releasing features multiple times a day, right? And that's exactly what they're using. Like they're using DevOps because they get to experiment. Like, should this button be red or green is no matter of discussion. Just develop it, A/B test it, get the data, decide. By the end of the day, you have your decision, right? Like that has come out of a discussion and has become a standard procedure that we execute every day, right? So the most important service that DevOps did, if I ask, anybody, they will probably say something different, but I think all of them are wrong, because the most important thing that DevOps did was that it reduced the cost of a mistake. If whatever feature I'm developing right now is the wrong feature, I will know it in a few hours, in a few days, right? Then I can learn from it and I can iterate. And it was such a powerful concept that it started going everywhere. So, a lot of you have heard the term MLOps, how do we do the same software development principles and operation principles that DevOps told us, but now bringing machine learning models into the picture, bringing, data into the picture, so on and so forth. Like, security ops became a thing, ABC ops, like, insert whatever name became a thing. But I think most of those ideas were still, pretty mechanical. They were the mechanical steps of the work that you were doing, and very knowledge-intensive work was still being done by humans. Like essentially observing the data and deciding, oh, I'm going to do this analytics on it. It probably means this. I'm going to interpret it in this way, and that means this decision that I'm like. That's a human process, right? So however fast your loop was, it was bottlenecks like how quickly humans can observe, interpret, and decide. Right? Not anymore. You have LLMs, you have large language models, and they're not good at judgment, but they're good at surfacing signal that humans can interpret much faster. They're very good at reading all the documentation and telling you, oh, we made this feature for these reasons, and here's 5 bullet points about it. And now in the data, I'm going to run some Python on the metadata that we collected. And okay, given this observation and what we had, here are the potential hypotheses we can have about the next feature. Before, this probably would have been a few days. If you had to discuss it in a big team, it would have been a few weeks. Now it is 5 minutes. In 5 minutes, you feed in your website data, you feed in your Jira tickets, GitHub issues, you feed in whatever other tacit knowledge you have, and the LLM crunches it all and throws out a bunch of hypotheses, and you're like, oh, I like this one and this one, so I'm going to try this next. Right? So that's what I call knowledge ops. Essentially, operationalize it. You know what I'm saying? That word of knowledge-intensive processes. Processes that took a lot of work to do previously that required knowledge and expertise, but now we're not going to automate. We are not automating them necessarily, but we're using semi-autonomous processes to significantly accelerate the process of making decisions, which again is significantly reducing the cost of the mistake. So these 2 hypotheses that I picked, even if they were the wrong ones, I get to experiment very quickly and iterate that, right? And that's the important value that knowledge ops brings to the table. So going back to where we started, which is startup founder in 2022, before the LLMs were as popular as they are today. They were probably, doing processes like this every single day, like maybe many times. And I'm using a startup founder as sort of a placeholder for any knowledge worker, right? So I generally mean knowledge workers. But any knowledge worker would figure out what their objectives are, prioritize a bunch of subtasks, start gathering information or using tools to crunch things, then test and reflect, and then refine and repeat and go through this process. Like this was a thing. This is a thing that all of us have been doing. We probably are still doing to some extent, right? And what in 2035 I think will happen is that that person is still in the loop, but this process is much faster. Instead of a half a day for each of these loops, she's probably doing it in 3 minutes, in 5 minutes, 10 minutes, right? So that lift in their ability to try things out and weed out all the mistakes is exactly the game that knowledge ops is promising. And these are all possible because of the capabilities that large language models give us, like that bottom left corner. They give us language skills, they give us reasoning skills, and they give us, tool usage skills. And, the color coding is consistent, by the way. So if we put all of these together, we can start executing this loop much, much more faster. DevOps people really love showing this infinity loop. And I have stole it from them to call it knowledge ops infinity loop. I introduced you knowledge ops infinity loop. At the intersection, at the core of this in DevOps sits the source code, right? So source code is the thing that you're iterating on in this infinity loop. Like you're just constantly making your source code better. Like that's a source of your knowledge. Sorry, that's a source of truth. Now that has expanded. It is still source code in knowledge ops, but it is expanded to other things like your prompts, your documents, your organizational standard operating procedures, or your marketing voice and tone, or whatever else, right? Like any type of documentation, any knowledge that you have is essentially part of this thing that you're iterating on. And companies that can iterate on that effectively have competitive advantage compared to anybody else. If you're using, the models are commoditized, everybody has the same models. What everybody does not have access to is that knowledge base that you curated over the past year, because you created a process that is compounding on that knowledge. Like every single time you use anything in your system, it is, teaching the system something. Like you're essentially using your prompts, workflows, whatever your organizational documents, you're integrating them into your workflows, you're using them, and then you're reflecting and figuring out, oh, this prompt could be improved in this way. My voice and tone document should be improved in that way. I don't know, like this prompt works well for me, but not for Joe. So, we have to fork it and keep 2 copies. Like those are things that are compounding, increasing hopefully your business metrics, but really that's what you're iterating on, because that's your driver, that's your business engine, essentially. Does this make sense?
Everything's a loop now.
What's that?
Everything's a loop.
Everything is a loop. We are in the loop. So again, like that infinity loop is where we would like to be, but where are we in near term, right? So the process of, I promised in the abstract of this talk that I will talk about how you build custom agents. And, a lot of these processes in knowledge ops are potentially done with custom agents. And by custom agent, I mean something that you sit down and write in LangGraph or AutoGen or whatever, all the way to, a very long and complex custom GPT that you save, right? Like all of these are valid, potential pathways to, parts of knowledge ops at least. But the way you figure out what is the right workflow is this evidence-based process of, first of all, understanding that when you talk about agentic workflows, it's not a 0 or 1 thing. Like it is not that you do have agentic workflow or you do not. You always have a little bit of agency and a little bit of autonomy in whatever you do. That little bit might be completely negligible, but it is not 0 in most cases. So whatever your current workflow is, it has some level of agency and autonomy, right? It might be a Zapier automation you created where it picks up your emails, sends them through an LLM call to summarize them, and then, I don't know, write a bunch of bullet points in your Notion, And then every morning you wake up and you look at your Notion and say, oh, okay, these are the emails I have. Right. So that could be your current workflow. You might not even be there, like you might be, a little less autonomous, a little less agentic than that, but you're somewhere. Oh, I forgot to also give you the difference between autonomy and agency. Autonomy means how much is the system operating without human intervention. Like all of the things that it does on its own until it stops and asks you a question, like that's autonomous behavior. And agency is how effective is its interactions with you? Like, is it so effective that you think it is your thought partner? Or is it like, oh, it stopped and asked me a question, like, it's more tool-like interaction, right? So that's what I mean by agents. Like coding agents probably started way that way. And today they're pretty good because they sometimes call you out and say, no, that's a bad design, right? Like a coworker, right? But before they were like, oh, that's absolutely right. That's the best idea I've seen in the world. Great, right? So again, like that's a movement on the agency, like how effective is the interactions with the system, and autonomy is how many things can they do on their own before having to stop and ask you a question. So there is somewhere that is your current workflow, some level of autonomy and agency. Then you go through experiments. You start, for example, writing some prompts and testing them out. Is that enough? Is that enough autonomy and agency? Is that enough improvement in my process to call this a day and just start using this? Most probably, it is good for a few weeks. Then you get greedy, and then you're like, oh, what if it also pulled in my calendar information? Right. So you start, imagining new things if that's working, and you start, adding, new features with every experiment. Like maybe you improve the user experience of whatever it is. And when I say user experience, I'm not talking about a web app necessarily. It might be the user experience of how ChatGPT or Claude is interacting with you. And we will play with those a little bit in the hands-on part. Sorry, I realize that I'm beyond the 30 minutes I promised, but I'm building up to something, I promise. So long story short, I don't want to go through all of this detail, but you do a bunch of experiments, and all of these experiments are there to inform you how to move in this two-dimensional space of agents and autonomy to figure out the right combination of all of the different ingredients, Lego blocks that you have, how do you put them together to improve the workflow that you have. And by the way, like sometimes you have to backtrack, right? Sometimes you overdo it. Sometimes you just try too much on the agency or autonomy, and then you're like, oh, things are on fire now, so I'm going to go back a little bit and put in more guardrails or whatever is necessary. And sometimes the experiments that you do not really touch autonomy or agency at all. The system is mostly working, but it is slow. So you might introduce engineering type of interventions, and this is where multi-agent systems, for example, get bored because you have created a system that is working pretty okay, but it is slow. So you just start refactoring it and giving it multiple things to do in parallel. If you're familiar with Claude Code, that's exactly the idea of the sub-agents. Most of the time, the sub-agents are used when you have a workflow that it works, but you don't want to spend half an hour on it. And there are a bunch of parallel things that can happen. So you just assign them to a bunch of the sub-agents to do that. Again, like if that's not a term you're familiar with, please look it up or let me know and I can explain it more. So a lot of these concerns that you have in terms of how the system can be improved ultimately come out of experiments that you run repeatedly. And that brings us to the topic of agentic engineering. So agentic engineering is the new take on what people used to call vibe coding. I mean, some people still vibe code, but those who are doing it seriously call it agentic engineering because we want to feel better about ourselves. So we're still vibe coding, but we do it right. They don't, whatever. So different branding, same idea. The core idea of it is the same as vibe coding. Like we don't want to sit down and write every line of code. We don't want to sit down and read every line of code. We want a system to take care of all of that for us. But we want to structure it in a way that at least we're pretty comfortable with the process, right? So we are not doing quality control. We are not writing every line of code, but we are setting up a process that we're like, okay, that's a good process. And through the experimentation, we fine tune that process, right? And that's exactly what agentic engineering is. And the holy grail of agentic engineering is what people call the software factory. And some people call it the dark software factory for dramatic reasons. And it is called the dark software factory, thinking about a manufacturing platform, manufacturing plant that is continuously manufacturing, but the lights are off because no human is in the plant, right? So essentially, the holy grail of software engineering, software factory is creating agentic processes, creating software processes, creating guardrails that allow software to be built in mostly autonomous way. So reducing the human intervention as much as possible, reducing the human bottleneck of review as much as possible, because we have processes that are very effective. Call back to what we talked about earlier. That's exactly what DevOps did for software engineering, right? Like they removed a lot of the manual checks with automated processes of checking. Now we are doing this at a much larger scale, which is the source code itself should be written with as little human intervention as possible, right? That's the holy grail, that we are not there. Because most of the people who hear this, they're like, oh yeah, I'm already vibe coding this to-do app for my. That's not what we mean. Like we mean proper, complex software that potentially can be solved as SaaS. Like some people who are doing this really well, they're reproducing, very sophisticated, SaaS systems within their company because they just burn a bunch of tokens and the system runs autonomously for a few days and comes out of it a software that is mostly good, right? It's a very good first attempt at building a replica of a Slack, a replica of whatever, with all the software robustness that it is. Like that's what it tries to do, right? Most of us are not there. Most of us are maybe starting to go towards that, but that's the goal. Like the idea is turn the lights off, go to sleep, wake up in the morning, you have a robust software system built for you. And that cannot happen by improving your prompts. It needs a more sophisticated system to be built around it. And of course, when we talk about custom agents, a lot of them are software systems. Well, all of them are software systems because we are not dealing with robotics in most cases. So, the same idea of the software factory is what I have grabbed and applied it to building custom agents. So it's a bit of a meta process too, right? Like if you figure out the software factory process, again, like you don't have to be at 100, it could be at 10 for all intents and purposes, then you can use that to build custom agents that push you up from 10 to 20, 30, so on and so forth. So it is a self-reinforcing process if you get it right. Does this make sense? Any questions about this?
How do you deal with the error propagation?
Yeah, that's exactly the big problem. So going back to this infinity loop, a very, very big part of this loop is that initially it's a relatively manual loop when it comes to software engineering, right? This is a super important part, right? Like you have to have this process and you have to have a knowledge base that is compound. So every time you run this process, a human is sitting here potentially and reviewing everything that happened. Like at the beginning, probably human is reviewing all the code, they're reviewing all the tests that are being written, but over time, the prompts and workflows start becoming good, right? Plus the models are becoming better. So at some point, the human starts trusting the process, not the outcome, the process, right? And that means that they can just iterate faster. So we essentially get to that point where the cost of mistake is reduced. Because instead of, like, if the human makes a bad decision in the planning phase, whatever, right? And set the loop on a bad decision, I will know it in a few minutes. Like in 20 minutes, I know that that was a bad decision because something on the user experience is not working, right? But that distance between the bad decision and the signal of it is reducing because I can essentially, even yesterday during the talks, obviously I was coding. Well, I was having Claude code, and I was using like some plugins that when it was building the UI components, it would automatically launch a browser, start clicking on things, figuring out why the color is not right, why, I don't know, the button is not working, et cetera, grabbing that feedback, bring it back to the agentic process. And I didn't even need to open it in browser anymore. Because now I'm using a plugin that automatically checks at least the mechanical parts. Like then, maybe 20 minutes later, I still open it in browser as the human, pilot of the system and say, oh yeah, by the way, we still haven't gotten these parts right. Sorry, the other question?
Maybe you talk about this later, but similarly.
Yes. I will talk about that. Yeah, absolutely. Okay. So sorry, I'm trying to rush a little bit because I'm well behind schedule. So a very good segue from all these questions to the fact that everything you're doing in this infinity loop is about the quality risk in your system. So every time you're doing one iteration on whatever your workflow is and the improvements you've made in it, you have to articulate what the most important quality risk in the system is and design everything around. Like at the beginning, when you're in the discovery phase, when you're ideating, when you're doing user research, when you're creating your evaluation data sets, everything is around quality risk. It's not like a random evaluation data set. It's a data set that is strictly about quality risk. Let's say the quality risk is, I don't know, the emails are not going to sound like me and the customer will know. Or the emails are too superficial and the customer will not like it, et cetera, et cetera. If that's the main quality risk, then everything about your evaluation, everything about your user research or whatever else you're doing is around that. Once you solve that problem to a level that you're comfortable with, then your quality risk moves somewhere else. It never goes away. It just changes shape. And then and as this software becomes more and more complex, like you go to the development process, you're figuring out the architecture, user experience, so on and so forth. You're still thinking about the quality risk. Like you're never developing software just in case. You're always thinking, what do I need to build so that I can understand my quality risk deeper and address it? So if the quality risk is technical debt, if it is, whatever the quality of the outcome at the end, then you proactively go after them. You don't ignore anything. You just design everything around it so that quality risk is always center and your experiments teach you something about it and then iterate on your solution based on what you learn. And this is my process for it. And the hands-on part we're going to do is going to give you some starter points. But generally speaking, any software project, including this building custom agentic systems, have a planning phase and execution phase. And you've heard many versions of this. Waterfall is that you spend 6 months in planning and then 2 years in execution. Agile is that you do that for 2 hours and you do this for 2 hours and then that for 2 hours and then this, et cetera, et cetera. Now, with what we have, you're probably doing this much faster. This cycle probably is happening every few minutes, every, I don't know, 30 minutes, every hour. But the steps are still pretty much the same things. Like, you're still planning work, like you're still ideating. Like, for example, here, like in the ideation phase, let's say you're ideating about something you want to build with Claude Code, with ChatGPT or whatever. And at the end of it, there's a document that is coming out of it. So that's a planning phase that you went through. And then you grab that planning document, that a specification document, and then you create a bunch of issues out of it. In my case, I'm doing it with GitHub issues. You might be feeding this into Linear, into Jira, into whatever issue tracking you use, into a bunch of markdown files. But usually out of the planning that might take about half an hour, comes out a dozen issues, let's say. You create all of the issues. As you're creating the issues, because you're going in a little more detail, you might realize that something about the planning might change. So you might make some updates into your plan. but you spend some time essentially planning work. And then when you come to the execution, and by the way, when you go to Lovable and stuff like that, you're not doing any of this. You're going there and say, make me a to-do list. And then you just talk to it about anything that happens. But what I'm saying is that you spend a significant amount of time planning here. It sounds like waterfall, but again, Claude is doing most of the work for you. You're just a master puppeteer here. And then in the execution part, instead of throwing a document in and say, go build this for me, please, you go through very structured processes. So I like to do test-driven development cycle, which means that when I begin work, I ask it to grab one of those issues and write tests for it. That's the first thing it does. And it doesn't write tests on its own. It brainstorms with me about, okay, given the issue, given the success criteria, I think these things should be tested. And I'll say, yes, well, maybe, how about this, we brainstorm. So that's the begin work. And then the tests are written. And when the tests are written, they should all fail because you don't have that software yet. And then you go to the implementation phase. In the implementation phase, you build until all the tests pass. And then there is a review by work phase. So essentially, we wrote tests, we wrote software, and now we want a review process. This review process should be grounded into whatever is important to your software, your team, your quality risk, and essentially should provide feedback to the implementation of the test and the code that you just added. So this review process essentially reads the plan, reads the GitHub issue we are working on, grabs a bunch of guidelines, organizational guidelines about code review, and then gives feedback. I personally do most of this in Claude Code, but this part I usually ask Claude Code to use Codex. So from within Claude Code, I say, hey, review the code. These are the guidelines, and by the way, use Codex to do this. I want to separate the models that are writing code and the model that is reviewing so that I have more likelihood of covering the biases. Sometimes if I'm working on something that I'm a little more hesitant about, I might do this multiple times, especially if the review brings back a lot of feedback. I might do this a second time, a third time, so on and so forth. And then there's the finished work, and that's Mars was asking about technical debt. This is the part that I try to reduce technical debt as much as possible. So once the tests are written, once the implementation is done, once the review is in and we tighten things up, then we have to essentially wrap things up. So finished work does things like, if we wrote any experimental code, get rid of them. If we have any auxiliary files, get rid of them. If the specification document that we had, if in the middle of this process, we deviated from it, we just ended up making a few slightly different decisions, go back and update them. If, I don't know, whatever is technical debt, right? They just go through a bunch of checkpoints and say, these are things that I surfaced, which of these do you want to fix? I usually say 1, 2, 5, and 10. A lot of the time I say just fix all of them because they all are valid, etc., etc. This keeps the code base really clean. It's not perfect, but it is really clean. And for the amount of effort I'm putting in, it's completely acceptable. If you don't have that, the amount of garbage that is compounding in the code base is going to be large, and your code base is probably going to explode at some point. Oh, actually, one of the things that finished work does that I just remembered is getting rid of any parallel implementations, because code and agents love keeping a few different copies of the same functionality for legacy reasons, like legacy compatibility reasons. And that's like 9 out of 10 times completely useless. So the finished work also double check those. Like if there are 2 implementations of purchase process, one of them is legacy, one of them is the new one we did, it makes a judgment, or it presents it to me as a judgment call that, do you want to keep both of these? Is this a valid legacy compatibility, or should I get rid of it? 9 out of 10, I get rid of it. So this keeps the code base quite lean and quite clean. That is super, super helpful. And the setup that, like I mentioned a few times, that I do this in Claude Code. Claude Code is a great choice because it connects very closely to your file system. So I use the file system as a persistent memory. It keeps track of any reports that come out of my ideation processes, any specifications that I write for my code, version control, etc., etc. It's a very long list of things, but essentially all of these are available to my AI when it is working, and it constantly is doing that process of acquiring context from myself as the user or my developers from the file system, shaping them, and then delivering them to the model that then takes the next step in whatever it is that we're doing. You could do this with Claude Code vanilla, like just as is. But we spend a lot of time, because that's our knowledge base, on creating workflows that are representing our standard operating procedures. Like, this is how we like to review code. This is how we like to begin work. This is how we like to finish work. Like, all of those are workflows that are very cleanly documented. If you're familiar with Claude skills or agents, skills are probably a better analogy. The workflows that I'm describing are exactly that. So these are, think about them as a bunch of skills that are available to your Claude Code system. We make them available as an MCP server instead of just local skills, because we want everybody to have access to the same, like everybody in all projects to have access to the same thing. There's another reason that we wanted to also make it available to our bootcamp participants so that they can go through the same agentic process. We call it Sherpa B. It is your Sherpa for building. And essentially, it like literally holds a bunch of YAML files that describe in a very detailed procedural way what our agentic engineering processes are. And the beauty of it is that it's not static at all. Every time that we are doing this, if we figure out that the system is not doing something right, we immediately go back and modify the YAMLs to improve them, to make them better. And that's our compounding knowledge that I was talking about. Right now, I'm not going to present this because this is very new. I'm also creating a system. Actually, if you were in the room where they were talking about the cognitive memory yesterday, I've essentially built that's work in progress. Like, every night, I have these scheduled processes that review all of the sessions I have done during the day. So every night at 11:45, it just grabs all of the sessions I've done today, and it sends them to the hypo model, Anthropic hypo model, and says, extract all the decisions that were made today, extract all the preferences that this developer had, extract anything that they said they like to be done differently, extract anything that they said something like, I prefer this over that. So it extracts all of the preferences, all of the decisions, and dumps all of them into a SQL database, and then runs a second process that essentially creates a knowledge graph out of it. And then the day after, when I'm working again, there's a retrieval process that fetches information from that knowledge graph, and anything that I say, it just grabs a few factoids and attach it to it. So when I say review this code, it knows to use my review process, but in addition to that, it also attaches a bunch of factoids about my preferences about reviewing, or my other developers' preferences about reviewing, right? That's a work in progress. Next year, I will present that, I promise. But essentially the core idea is, how do you make that compounding knowledge as autonomous as possible, so that, the days that you don't feel like it is still compound.
Yeah, well, one of the big challenges is like how to avoid the noise when you store the factoids.
Yes.
And I tried to do this part of it, and I'm still struggling, but
Yes.
in progress. And then the other thing is, like, you do this cycle thing at night. You said so. I guess you still need the human in the loop to see what
I don't. So to address both problems, that's the knowledge graph part. So the knowledge graph part is done using a better model that I trust the reasoning more. And what it does is that, for example, it says this factoid that was extracted today is a duplicate of another one we had, right? So then it's not just collecting the same thing again and again and again every day. It just knows that all of these are duplicates, so it just ignores all of the duplicates. Or this one is the reason for that one. Or this one is a generalization of that one. etc., etc. I'm also, I haven't done this yet, but I'm also adding the concept of support. So is an idea, is a factoid a supported factoid or not? If it is an isolated factor, I probably want to drop it. Like if it is something that is not connecting to anything else, it might have been a spurious. So I think that knowledge graph definitely is not going to eliminate it, but it's going to reduce the noise. I'm also implementing a temporal decay in the ranking part. So where when it is retrieving factoids to add to what I just said, like the thing that I said about reviewing code 6 months ago, if it is not super supported, and if it is not repeated at all in 6 months, then it probably will just naturally go away in the ranking. So it's not, I would recommend looking at, there's this library called Aura SDK, if you haven't seen it, AURA SDK. Like a lot of the temporal decay, I'm essentially stealing from them because that's what they do with their memory.
Do you have any thoughts on working with a multi-repo code base and also a legacy code base?
Legacy, no. I fortunately haven't had the pleasure of dealing with legacy code much. Sorry, what was it? Multi-repo. So multi-repo, like using a server is one way of dealing with it. Like essentially when all of the processes are in a server, you could just add them to all your projects. The second thing is tools like Claude Code allow you to do profile level configurations and skills. So that can apply to all of your projects. Beyond that is just the typical engineering stuff that you do, like submodules and so on with multiple repos. Right. I'm not a software engineer, so I don't know how to answer that well. But what we do is that we index very, very heavily on type validation and schema validation everywhere. Like anything that is dealing with data is definitely typed, even in Python, and is definitely runs through a lot of schema validation. And all of these workflows that I was showing here, again, like nothing about is perfect. Like next week is probably going to change some of it. But like each of these do commits, like they do git commits, and the git commits, all of them have pre-commit hooks, and the hooks run through all the tests and validations. So hopefully the errors will not propagate in the system. I don't know how to do this well with multiple repos, if I'm honest, but at least within the same repo, we put a lot of guardrails around any agentic code changes to just mess up the schema.
How many tokens do you churn through in a day?
I don't know. Our monthly bill for 3 developers is about $1,000. It's not huge. We also don't really there's a whole conversation going on right now about token maxing. If you're not burning all the tokens in the world, you're not doing it. I think that's a narrative pushed by those who make money from token maxing. So we actually, in my community, we had a talk yesterday where we brought in a designer to talk about how she essentially does all of this stuff but for the user experience and the UI. And one of her biggest messages was that your prompts should be very, very short. And I was like, that's counterintuitive. I'm going around and telling people they should write very long and descriptive. And she was like, I'm not saying any short prompts. I'm saying do your research, learn the lingo, and then write a prompt that is exactly on point. And since she knows the language of design, she knows exactly how to explain what she wants. And 9 out of 10, she gets exactly what she imagined. And I think it's a bit of that, like token maxing is the narrative around brute force, like throw in, see what happens. And there's a counter one that I think is what I'm supporting, which is more intentional, more thoughtful, plan it, invest heavily in your processes so that overall, even the token consumption reduces over time. Like that memory that I described, my biggest motivation is reducing token consumption because I don't want it to do a bunch of things for the 15th time. And then I say, hey, you made that mistake again. Please go back and fix it. Right. Okay. Hands-on part. You have 20 minutes, so you you can go through it still. Again, like you have this, you can do it at home. You don't have to do it here, et cetera, et cetera. But I'm gonna just switch quickly to what you are supposed to see. Okay, so if you scan that QR code, it should bring you to this part. Again, like the top half of the page is around setting up your cloud code. This is, by the way, this is the process that we do in our bootcamp. This is just the documentation related to that. We are making it available to you, so use it if you want. If you want to do this with us, there's always the option of joining the bootcamp. There are a bunch of CTAs in here that you can do. But essentially, the way you do this setup is that we have prepared some prompts for you that you can just copy, go to your tool of choice, I don't know, Gemini, and put that in and press enter. Like that's really all you need to do. And what this is going to do is that it's going to guide you through the process of setup. So you don't need to, sit down and watch YouTube videos about how to set up Cloud Code and whatever. You can just copy paste that, and it will guide you through the process. It should do it a step by step. If it is not doing that, stop it and ask it to just do it a step by step. And the beauty of doing it this way is that it has all the context of what we are trying to set up. And if you run into any problems, like it is very common that, for example, if you're on Windows, I don't know why you are, but for whatever reason, you might run into more problems. And then you can come back here and say, hey, I'm on Windows for whatever reason, and I'm running into this error. How should I navigate it? And it should be able to help you do that. So this is an example of me identifying my teaching. So instead of like sitting down with every one of you and holding your hand, I'm giving you a prompt that you can use. And then Gemini has way more expertise and also importantly, patience to help you go through this process, right? So once you're done with this first one, again, like you can also read this prompt. Obviously, disclaimer, don't copy prompts from the internet and put in your AI because dangerous. So, skim this, make sure there's nothing dangerous. I promise there's not, but, best practices. So you can read it or you can trust me and just copy prompt. Once you're done with that, you can ignore this one. This is for our bootcamp. And then the next steps is where I have made simplified versions of what I'm using for all the process that I described here. So essentially, if you want to ideate about something you want to do, like you want to say, hey, I would like to build an app that helps me fetch my emails, see which ones require a meeting, and book all of them for me. Let's say that's what you want to do. Instead of just going to Lovable and start writing that, you hopefully come here, copy this ideation prompt. And what this ideation prompt will do is that, again, like this is a simplified version of the YAML files that I described. We'll go through this process of brainstorming with you. Like, okay, let's frame your problem properly. What is this problem? Why is it important? Da, da, da. Importantly, it's going to challenge your assumptions. Instead of saying, oh my God, this is the best idea since sliced bread, it's going to say, well, your idea sucks for these reasons. Like you're making these assumptions. Are you sure about this? So it's going to be like a thought partner that forces you to think critically about things, et cetera, et cetera. Then it comes up with a bunch of solution options because almost every single time the first idea that came to mind is not the right solution. So it pushes you to expand out a little bit before deciding. So it says, given the framing, given the assumptions, here are all the possible solutions. Why are you stuck on that one? Like, what do you think about this one? What do you think about that one? And then you converge on a solution, which is usually a combination of all the above. And importantly, at the end, it asks you to design an experiment. So given what we discussed, what is the thing that you can do quickly that will help us understand the assumptions you're making better, right? So a typical ideation session might take, if you do it right, it might take at least half an hour. With our extended version that we use in the bootcamp, that usually takes even 60 minutes, 75 minutes. But it really depends on how engaged you are with it. Like if you really thoughtfully try to answer all the questions, I would say 30 to 45 minutes. At the end of it, it will write a document for you, and that document is your planning document. Okay, and so that becomes one of your planning documents. Hopefully, you want to create an evaluation data set. So I strongly encourage you that for whatever idea you're working on, to create evaluation data sets. An evaluation data set doesn't need to be this complex, CSV or SQL database or whatever. It could be literally 10 test cases. And the reason that that's important is that you're going to come to me and say, hey, should I use this model or that model? Should I use this architecture or that architecture? Should I use this whatever or that whatever? And 9 out of 10 times, I'm going to tell you, what does your evaluation data set say? Right? So a lot of the decisions that you have to make will come down to those test cases and how that decision is going to impact those test cases. And this is going to be a core set of test cases. And later you can expand it, add more edge cases, so on and so forth. Eventually, you could even automate some of this using a process called LLM as a judge, which is this evaluation at a scale thing that you can do at some point, so on and so forth. Like, I don't want to go through these one by one, but this one is one that I would draw your attention to, which is the context management workflow. If you're building agentic workflows, almost 100% of the problems you're going to run into are going to be context problems. Your system is hallucinating. Why is that? It doesn't have the right context. It is relating concept A and concept B out of thin air. It's because you did not explain concept A and concept B enough to it. You did not connect it to the document sources that explain these So a lot of the problems you run into is stochastic behavior, hallucination, list whatever long list of LLM problems you can imagine. Almost 100% are context problems. You just have not done a good job bringing the context to the agentic system in a way that enables it to make the right decisions, right? So this context management workflow helps you think through that. Context management is a very, very interesting topic. In the previous world, we called it prompt engineering, but then we realized very quickly that it's not just the prompt engineering part. It is, all of the RAG setup that you have, all of the document sources, all of the SQL data you're bringing in, and everything that you sort of orchestrate and a stage for the LLM to use to make a good decision. So it is really, if you're completely honest, a rebranding of data engineering. And we call it context management because it is cooler for some reason. Anyway, so that's so these 10 workflows that are on the top are going to be your planning workflows. And then there are the project management and execution workflows that I described. So in one of the slides, I said that I go through that process. I have provided a simplified version of what I use there for you to get started with. And by the way, one of the things that this setup prompt will encourage you to do is to set up to learn about Claude skills, because you could set up essentially any of these as a skill. like anytime that you want to do ideation, you can go to Claude Code and say /ideation, and it just picks up this workflow and it starts ideating with you, right? So I encourage you to do that. And you can do the same thing with these. Like these are actually more important to set up as a skills, because hopefully like the begin work, review work, and finish work is something you're doing constantly. Every time you're doing a session, you sit down in your chair, you open Claude Code, and you say begin work. And then it knows exactly what your process for that is. And again, like I'm giving you simplified versions of this to just initiate it, to just seed your process, try them out, adapt them to your preferences, improve them over time as you use them. There are a couple of other ones. There's the create issue one. I usually like the create issue to not be in the absence of information about where the code base is. So the create issue, for example, also reads a bunch of files that might be relevant to the issue you are creating. And then it creates a very detailed issue saying, oh, potentially we have to touch these files in these ways, et cetera, et cetera. But again, like you can improve these. Since I'm heavy on entrepreneurship, I'm releasing 10 new workflows like these also for go-to-market strategy. So let's say you've gone through all of this and you build something, and now you're like, what can I do with this? So hopefully those workflows will brainstorm with you about how do you find your customer for your natural language to SQL or any other project you're working on. How do you talk to these customers? How do you sign them as design partners? All of those things.
Will that be in a GitHub repo or on this page?
It will be on this page.
Okay.
Yep. For anybody who's interested to know more about how we're using this in a bootcamp, there are links everywhere. Click on them. But the specs of our MCP server, the Sherpa BMCP server that I showed on one of the slides, is also here if you're curious to take a look at it. So feel free to go there and check things out. I know I have 5 minutes, so I want to go back to the slides quickly. Is there any questions about what I showed here? I know I was hoping that we do this actually together, like at least the ideation, but
I came in a little late. You said there was a QR code to bring to this page.
yes. Sorry, give me 1 second. This one. Any questions?
Is Claude code skills or do you have to make your own?
It has some off-the-shelf skills in it. Just type/skills.
Yeah.
Nothing? Okay. Yeah. So then no. I honestly don't trust. Skills is one of these things that there are like a zillion of them on the internet, and I don't trust any of them. I always create my own skills, but
Claude has started an ecosystem called plugins.
Hmm.
So if the latest version of Claude Code look about plugins, like /plugins. You can add marketplaces, one of which is the Claude official marketplace.
Right.
You can search and get install from there.
yeah, thank you.
So that's new-ish for the plugin.
You work that you've done so far.
Often, yeah. So in coding specifically, that happens quite a bit. That it starts making a bunch of stupid decisions, and it just, like you were saying, it just cascades until some point that I'm like, oh, like, what are you doing? Like, stupid, stop it. I heavily use Git to just roll back. Like, if it is not recoverable, I just say, just drop everything up to this commit and start over from there. We also use the usual, branching processes, etc., to avoid contamination of the main branch.
I don't like drop anything.
No, God, no. Like we don't allow it to go that far. Like we have very strict guardrails that, anything that touches production directly has to go through here. They're not that good. Yes.
Amir, can you share a little bit like what the structure of your specs look like? Like what it means for
They're not super structured. So I know a lot of people are proposing a bunch of different ways to structure, like YAML and this and that. I just write simple Markdown. I use the specs mostly as sort of a seed into the the issues. Issues are really the ones that I spend more time on getting right, because usually specs are written a little bit in the absence of the deep, like the exact details of the source code. So they're a little more high level. They're like more like an epic, if you wish, in Jira language. But then I throw them into the create issue process, which checks the code exactly and figures out what's what, and then writes, I don't know, a dozen detailed issues for what. Those issues like definitely have a structure like current state, desired state, success criteria, checkbox of how you're going to test it, da, da, da. I have 4 minutes. I want to quickly show you something cool I did in our kitchen, out of all places. So my wife always is brainstorming about what we should have this week for meals. And she just comes to me and starts talking, and I'm like, babe, I cannot keep track of all of this. So I created an agent, or I started creating an agent that would listen to her and create a shopping list for her. And he's a lot more responsive than I am, and she does not like that part of it, but but it works. It's practical. So I started with this idea that, give me a voice note, I'll give you a shopping list. End of the story. No fights, no nothing. And then over time, as I was building this, I realized that it's way beyond that. It is like, keeping track of the fact that I want to have more protein. She wants to have more this. I don't know, this week we're going to be away, we have guests, her mother is visiting and she's diabetics, etc. And the reason that I ended up with something more interesting and more sophisticated was that I went through these ideation processes. I built using what I described and tested it. We just literally tested it in our grocery shopping trips. And then eventually ended up with a relatively sophisticated architecture, right? That I probably spend a couple of hours every week on building this, along with the bootcamp participants. I just wanted to show them an example. And, Cloud Code has written 100% of the code for this. We collaborated on architecture, so on and so forth. Now it's a system that we use, like, we SMS it, everything that we want to keep track of for buying. She sends pictures of, recipes from New York Times, and just grabs them and adds them to the database. Right now, we are expanding it to the household resource planning tool for like everything in our household, like the garden management, the medicine cabinet, et cetera, et cetera. I probably spend, I would say maybe not 40, even like 30 hours active on building this, but it's robust, it is working. It craps out, obviously, but a lot less than that 30 hours warrants. There's a short demo video of this on our website as well. You can go take a look at it. But that's it. Thank you, everybody. Hope you enjoyed it and found it useful. I will be around for the rest of the day. Come talk to me. Thanks.